Hello, my name is William Bridges. My co-author was William or Bill Rhodes. This paper is based on research and actual implementation we've done at many sites on implementing human factors at the worker level, at the middle level, engineer level, at the management level, senior management level. And it's based on other papers that have been presented at these GCPS conferences. I want to talk here about how we're going about the best way to implement human factors at the worker level. So first, the workers need to understand what human factors are. This is a new thing for most of them. They haven't been taught human factors before. We'll go over that in a few minutes. Then once the workers understand human factors, they can implement uh, some big pieces of it, and we'll talk about which elements fit in their responsibility here in a few minutes, and they can take the lead on those. They can also mitigate other human factors by pointing out deficiencies and communicating those to management, and on insisting that the human factors be in the correct state before they proceed with the job. And finally, we'll end with what can management do to enable the workers' success in implementing human factors. In training plant workers on human factors, first they need to understand what is human error and why do humans make mistakes and that everybody makes mistakes. And that includes a good overview of human factors. So all accidents are caused by human error, either directly by a mistake made by the worker, such as an operator in a plant or process, or indirectly, such as by maintenance and reliability errors causing the failure rate of equipment to be higher than normal. They also need to understand that the root causes of these weaknesses is not them, it's management systems. So we put management systems in place for how to write effective procedures, how to control task design, how to control remedies for human error, how to control communications. All these have management systems. And so management system weaknesses are the root causes to all accidents as described in CCPS textbooks. And so we train them on that aspect as well. What's the root cause? And then finally, they will understand by that time that weaknesses in human factors lead to more human errors. More human errors lead to more near misses. And if the near misses aren't reported and investigated, that will in turn lead to more accidents. We train them on what goes into the overall control of human error. So first we have risk assessments we do that try to predict accident scenarios caused by equipment failure or human error directly, and the equipment failures indirectly caused by humans. Against these accident scenarios, maybe discovered in a PHA, a process hazard analysis, we implement barriers or independent protection layers to make sure we have proper risk control of each accident scenario. So the human reliability is all part of maintaining those barriers and maintaining the prevention of the causes that start a whole accident sequence. These management systems include high-level management systems like process reliability, equipment reliability, quality assurance, and also process safety management. And at the implementation level in the plant, they overlap. All these management system thrusts overlap with each other. So we have one operating procedure for controlling what operators do during a certain mode of operation. We have one maintenance procedure for how to repair a pump, not multiple ones, one for environment, one for safety, one for occupational safety. So these implementation levels is where we're focused on with the workers. Of course, not all management systems, no management system is going to be perfect. So we need to have root cause analysis to learn where the management systems are weak or where the remedies are weak and be able to gradually and continually strengthen those. When we talk about human factors, what we train the workers on are all human factors, even the ones they're not directly responsible for. And we train them on an overview of the statistics as well. The statistics being what's the probability of human error if all human factors are optimized, and then what's the probability of human error if some of the human factors are deficient. And on the right-hand side of this table of human factors, you can see the multiplying effects that we've estimated over the past 30 years, 40 years of data collection, where if you have a weak management system, it can have this impact on the probability of human error. So let's take an easy one. If you're not controlling fitness for duty very well, and the worker is very fatigued when they're starting into a task, then at extreme fatigue, they can have 20 times the error rate as they would under other conditions. So if their normal baseline optimized error rate is 1 in a probability of 1 in 100, now there might be a probability of 1 in 5. And we've seen this in actual accidents where there's been high fatigue involved. So once the workers understand the human factors, and especially those ones we're going to give them direct responsibility for, then we can start making some assignments. And so we really want them to take the lead on selected human factors because they're really in a better position than everyone else. They're working in that human factor all the time. So this could be an operating procedure or verbal communication, as we'll see in a second. And they've been trained and coached now on what is human factors. And of course, they might need additional training on the in-depth implementation of a specific human factor aspect. But they're in a unique position to do that, and these combination of hands-on right there, seeing it all the time, and the proper training makes them ideal to put in charge. So what can we assign to their responsibilities in human factors? How to control verbal communication. They can take the lead on that, whether it's on radios or public addresses. We'll go over some simple rules for that in a minute. Writing, operating, and maintenance procedure. So operators should own and write operating procedures. Maintenance, reliability staff should own and write their procedures. We should develop troubleshooting guides. Again, that should be operators who take the lead on developing troubleshooting guides. Other people, like process engineers, have a role in here too, but we're talking about who takes the lead, who has the ownership. Then there's other aspects of human factors that we may or may not assign directly to the worker, but they have a leading role in some aspects, such as the human system interface. If the human system interface is deficient, before the training, they may not know that, but after the training, they do. And so the workers are in a great position to point that out, as well as to point out remedies, which we'll go over later, on preventing human error or compensating for human error. They can help us spot those once they know what those are. For communication, the main rules are repeat back of everything you hear. So if you're the sender, you repeat back. The receiver has to repeat back, and if you're the sender, you have to require the receiver to repeat back. Spelling out letters like Alpha, Baker, Charlie. These common rules, as you see implemented in airline industry, for instance, air traffic control, are very important in a chemical plant, and they're only implemented maybe 5% of the places we go, and usually only for emergency response. But day to day, we've seen these implemented in units and plants, and very effectively, and the error rates go way down if you have a really good communication standard. And the workers don't mind enforcing this once they know it's their responsibility and why it's so important. Uh, Writing operating procedures, maybe not every operator and every maintenance can write an effective operating procedure, but they should be able to read them. And probably 20-25% of the staff would make effective writers by our calculations. If they're in their mother tongue, if they're in their mother language, the language, their first language. So now what they have to do is learn what's the best practices for writing procedures. Yes, we want them accurate, but we also want them clear and written in such a way to where they encourage people to follow them and not make an error. So there's rules for how to lay out a page of a procedure. There's rules for how to lay out steps of a procedure. And from a worker implementation, they need to learn these. So after a couple of days of training and then maybe 3 to 10 days of coaching in the field, most of the writers have learned the lessons they need to write, and they can develop really effective operating procedure following the best rules for the layout of the pages and the best rules for writing the steps of a procedure. So then we can turn over that whole job to them. We might need to give them some clerical support and engineering support, of course. And so the work product could be a very clean procedure that follows the human factors and doesn't have anything in the way of doing the job correctly. We can also assign to the workers the development of troubleshooting guides. Troubleshooting guides is a class of procedure, but it's a response procedure, not emergency response, but response to a trouble alarm. like a high pressure alarm, a low level alarm, a high level alarm. And so the trigger for the procedure is the alarm. So that is like the title of the procedure. But the workers have to be trained on the best way to write these troubleshooting guides. And then they have to, of course, ensure that people are trained and the training is, and the drills are done on each of these troubleshooting guides and that the drills are timed. But what goes in a troubleshooting guide that the operators will be writing? There might be some immediate action they should take, and the workers would know what that is. So there might be the alarm might be false or real. They should be trained on how to determine that, and so they can write down the steps that would have that in there. Uh, then they would know best how to find and fix the problem, find and fix the cause, and finally, if they can have a permanent fix right away, or bypass the problem, or if they have to go all the way to a shutdown. So each troubleshooting guide has these 4 sections in it, and there might be a few bullets in each section. So operators can easily learn to write these and maybe even help get these uploaded as a standalone screen in the DCS. On elements that they're not directly responsible for, they can still take a leading role in improving them. So if an operator was given this local panel in the field, there's chances to make selection errors here because all the switches from a distance look the same, all the lighting looks the same. So once the workers are trained in human system interface a little bit, they can start recommending improvements. And some improvements are really simple, like just outlining which group of switches all go together and for what purpose. And so workers, even though they may not make this physical change themselves, they might make some changes. And maybe we'll put them in charge of human system interface issues like labeling, color coding, direction and pipelines, and things like that. Also, workers are, after they learn that there are such remedies, they can recommend where a human system prevention error proofing might be really helpful to lower their human error and lower the human error of their friends and co-workers in the field. Workers can also help mitigate any error likely situations by alerting management of the situation or by exercising their stop work authority, for lack of a better term, uh, and enforcing the proper rules. In this case, not on other workers, but on the job. So in this particular case, a worker was given the scaffolding to do a job and then asked to do another job. Well, obviously the scaffolding isn't very good for the second job he was given. And you can see him climbing on the outside of the scaffolding and even standing on a round handle valve. This is not good for the worker. It's also not good for that valve, especially if he steps on it and turns it. Any number of bad things can happen. So in this case, the worker needs to insist on having the proper job set up. The same is if you don't have the right tools. In this case, a group of workers were tightening bolts, like shown on the end of this drum, and they didn't have bolt tensioners, hydraulic bolt tensioner. And that would be really bad in this case because this is a 60 bar, 60 atmosphere drum, very high pressure. And standard wrenches and hammers just won't get those bolts tightened correctly or to the right torque. Workers can also communicate problems even with the management systems themselves. So they may not be able to do this right away, but that they're at least in a good position to. And many times the owners of the management systems don't even know they have deficiencies. So the more workers get into human factors, the more they'll understand the underlying management system that's trying to control that one human factor. How do we enable the plant workers' success in doing all this? Well, management, of course, needs to set a process safety culture, and that primarily comes from establishing a core value of human factors in process safety. And the two go hand in hand, as I mentioned. So they need to make sure that the worker knows that human factors are things we're paying attention to. We're looking to improve the human factor, not make you perfect, but make the human factors as perfect as we can so that our error rates are low. That all humans make errors, including workers in the field, including management. So management can admit to that, as we talked about early in this presentation, and set the tone right. They can let the workers know this is a long-term focus. This is not a fad. It's not going to be here for 2 years and then just go away. So the leaders need to be the leaders and show that this is a real core value. Um, and the biggest way I see this happening is these next 2 points. If management doesn't put the money, the investment of time and resources, then things aren't going to get done on human factors the right way. So money talks, as we've always learned. So if we invest in the development of the right equipment and from a human factors perspective, and in the right procedures and training from a human factors perspective, then we can control human factors. And if we train the workers how to do their job in human factor optimization, they'll get the point and they'll start doing a better job of this. Part of that leadership role is also making sure we have a blame free environment, that we're not looking for who just made the mistake. We're looking for why was the mistake made? What can we do in improving a human factor that affects the performance of maintenance or reliability people or the operators, so that their human error rates and the company performance can be as good as possible. So having a learning, questioning environment, having a blame-free environment, especially when near misses are reported, so we can learn from those, is critical to the success of this program. I want to thank you for your attention. I encourage you to read the paper and read some of our other papers as well. Bye for now.